Here's a solution for problem 7.6.49 from Rockswold's algebra. The problem is to solve this equation with rational expressions. Also check your answer. So we've got 3 over y minus 1 plus 1 over y equals 5 over 4. To solve this sort of equation, the idea is if we can find a least common multiple of all of these denominators, we can multiply the whole equation by that and it will clear all of these denominators. Then it will be an equation that doesn't involve rational expressions. So over in the margin here, let's find the least common multiple of these denominators. So for the denominator y minus 1, we're going to need a factor of y minus 1. For the denominator y, we're going to need a factor of y. And for this denominator, on the right hand side, 4, we'll need a factor of 4. That final one is sort of optional, the 4, but if we throw in a factor of 4, we'll even get rid of the fraction on the right hand side as well and make everything integers, which is kind of nice. So our least common multiple will be 4y times y minus 1. Alright, so let's come back to our equation and multiply both sides by this least common multiple. So 4y, y minus 1. And then distribute this like that. And on this first term, we're going to get 3 times 4 is 12 times y minus 1 over y minus 1. For the second term, where you get 4y times y minus 1 over y. And then on the other side of the equation, we get 5 times 4 is 20y times y minus 1 all over 4. And then notice that all of these denominators cancel. This was really the whole point of multiplying by the least common multiple like we did. In this first term, the y minus 1 cancels. In the second term, the y cancels. And on the right-hand side, the factor of 4 cancels. Really, we didn't need to multiply out the 4 times 5. We could have just left it unmultiplied. All right, so clearing away all the stuff we canceled, we have 12y plus 4 times y minus 1 equals 5 times y minus 1. Okay, so now this equation doesn't have any rational expressions left. It looks like if we just multiply everything out, we will have a quadratic equation, and that we can solve by factoring, hopefully. So we get 12y plus 4y minus 4 equals 5y squared minus 5y. And combining like terms on the left, 16y minus 4 equals 5y squared minus 5y. And then moving everything to the right, subtract 16y from both sides, add 4y to both sides. I'm sorry, add 4 to both sides. We get 0 on the left, and on the right we get 5y squared minus 21y plus 4. Okay, to solve this, we need to factor the right-hand side. Hopefully it does factor. If it doesn't, we're kind of in trouble. So we need a 5y squared, so we'd better have 5y and y. Also, we need the product of the two constant parts to be positive, but to get some negatives, we must have negative, negative. All right, now we need to pick factors of 4 for these two blank spots, and somehow end up with the middle term being negative 21. To get something this big, we probably want to multiply the 5 by the 4, so that means we should have the 4 over here and a 1 right here. Now this is a guess at this point. We should quickly check in our heads. 5y times y is y squared. Negative 1 times negative 4 is positive 4. And then for the cross terms, negative 1 times y is negative y, and 5y times minus 4 is negative 20y, so that's negative 21y altogether. So this factoring is correct. So now we can finish solving. So we'll use the zero product property. Since this product is equal to 0, that means either 5y minus 1 is 0, or the other possibility is that y minus 4 is 0. And then each of these we can solve individually. Move that minus 1 over, 5y equals 1, or y equals 4. So one possibility is y equals 4. And then to finish off here, the other possibility is divide by 5, y is 1 over 5. All right. Of course, if you are working on this problem online, your numbers might be different, but the ideas will be the same.